All right, so let's go ahead and go over these basic functions, exponential functions. So we want to be able to solve this by kind of getting an understanding on how to use our y equals a b to the x, right? So I'm gonna write it up here because this is what we're going to be dealing with this type of problem is y equals ab to the x. So it says a new car is purchased. The first thing I think about when I hear a new car, I think of decay. I think of depreciate value. I don't think of growth, right? So it says purchase for $18,500. The value of the car depreciates. So this tells me we're not talking about growth. We're talking about depreciating value at 10.75% per year to the nearest year. So we're going to round up to a whole number. How long will it be until the value of the car is $5,000? Right? So what we have right here, right now, we have our initial value, which we're going to say is our A, and that's 18,500, right? We're going to have our B, but again, our B depreciates. So that's going to be 1 minus our rate, right? And then we're going to have our Y be equal to the $5,000, and our X is going to be equal to the years that we're looking for, right? And so now we want to be able to calculate what our B is, right? All right, so let's use another screen that's going to give us a little bit more freedom to work with here. So we got y is equal to a, b to the x. A is 18,500. B is equal to 1 minus r. Y is equal to 5,000. R is equal to 10.75%. Right. All right, so what we want to do first is we want to write our percentage based upon our B, right? So we're going to do 1 minus 0.1075, and that's going to give us a value of 0.8925, right? So our Y is 5,000, so we're going to set up a problem now. We have 5,000 is equal to our A, which is 18,500, and we have 0.8925 to the X. And so now anytime you have an X there raised to the X, you know we want to solve for that X. The only way to get that exponent out of that is we're going to end up taking the log of that function, right? So we're going to end up dividing 5,000 by 18,500, and we end up with 0.270, right? I'm gonna round it to that point, and then we're left with 0.893 to the x, right? So again, once we take the log of these two functions, we'll have the log of 0.270 divided by the log of 0.893. And once we take the logarithm of both of those, then we will have our answer. So the logarithm of 0.270 divided by the log of 0.893, and that gives us an answer of 11.56. And they said they want us to round to the nearest year, so that will be 12 years for this answer. Right, so as we look at the details a little bit one more time, you can kind of see how we set this up and how we do it. We got to be able to take the logarithms to find the exponent value x, and that is our years. So let's go ahead and do one more of these, and I think that will suffice. All right, so I don't want to do a new car, So let's try to find a different question. All right. So now we have one where we're talking about interest and we're talking about money. Reason why I wanted to do this one is because this one is about growth, right? So we're going to have a different equation here. All right, the question set up, it says $7,100 is placed in an account with an annual interest rate of 5%. To the nearest tenth of a year, how long will it take for the account to value to reach $26,400? Right? So again, we're talking about our A is smaller than our Y, right? So our starting amount and our end amount, our starting amount is smaller than our ending amount. So that means we have growth taking place. So that means when we get to our equation, our B is going to be 1 plus R. If our A is larger than our ending amount, then we know we have 1 minus R like we had in the last equation. So B is equal to 1 plus R for growth. B is equal to 1 minus R for decay or depreciating value, right? So right here, right now, we have it set up already. We have our A. So let's go ahead and start working on our problem. So our Y is 26,400 equal to our A, which is 7,100 times our B, which is 1.05 raised to a power of X, right? So now we know we're going to have to divide. So we're dividing both sides by 7,100, right? And when you divide 26,400 by 7,100, you're going to end up getting 3.718, right? And again, here we're going to take the logarithm of this function, and we're going to have the log of 3.718 divided by the log of 1.05. So after putting that in the calculator, log 0.3718 divided by the log of 1.05, that is going to give us a value of 26.9. So we go back to Delta Math and see what they want us to do. They want us to round it to the nearest tenth of a year. So we have 26.91. So that means we're going to have 26.9 years, right? And again, here's the breakdown of what we just went through, what we just walked through, and what we just explained. We see the exponential growth was positive because A was smaller than our Y. And so here's our function written out and worked out to find what X is. And our years are 26.9. All right. And so that's two questions there that we just walked through and we just did. Again, I think this suffices for the moment. If you guys have any more questions, please don't hesitate to reach out.